What is this about? Okay. Today's is the 25th of January 2026. The time now is 9:14 p.m. This video is on by OB Nexus, Namdi Michael Abba, the founder of OB Nexus, the world's first design and decision constitution. Biological activation, recognition for authentication and for authentication or authorization. Let's give you the UI, the problem UI. So, the problem more less formally. So, take this sheet of paper you work on. It's a standard A3 sheet of paper. I'm gonna fold it in half. So I'm folding this A3 piece of paper in half. But this is A3 piece of paper. I fold it in half. And I now have double the sheet of paper. And then I now take it and fold it in half again. This is another double sheet of paper. So I now get the A3 sheet of paper folded in half, double, so it's folded twice in half, folded once in half and twice in half. So it's basically half twice. So it's basically half and half. So you get two A4 sheets of paper. A4 sheets of paper, you fold in half. But these two halves are literally, what the whole point is. You fold it in half again, I fold it in third time in half, and then three halves, and we're done. So now, fold it in half, three halves. So you get, if you think about the duration, 3 times a half is basically 3 times a half, which the half is the half of 4. 3 times a half is what? 1.5. 1.5. So this the dimensions are reduced 1.5 times. Let me just fold it again. 4 and 5 times. 5 times. Can I? Yeah. 5 times. So this is basically A4 sheet of paper. So 5 times a half. 2.5. So this fold is for 2.5 times. Of the it's basically reduced 2 point. Basically, the paper was we have a standard A2 sheet of paper, which is reduced by which is 30 centimeters to 15 centimeters, reduced by 2.5 dimensions. So if I do 2.5 times 15 centimeters, I'll get 37.5 centimeters. This is basically width and height of an A3 piece of paper. I get never do 2.5 times 30, give me 75 centimeters. So basically, this is 10 centimeters height and width, respectively. That's folded of 2.5. But this is basically how you calculate things of human rights of a half. But human rights of a half would be like half plus half plus 14, half times half equals 1/4. You share, but don't worry about that. It's usually for problems of disability and discrimination. So 1/2. So if my human rights are 1, you have 1 dimension, and that equals 1 human right. So 1 plus 1. My eyes, 1 plus 1. I have 80 human. So I am tripolar. So I can see human right to be existing of tripolar. That's 1 plus 1 is 2. 2. If I add up, and then 1 times 1 and 1, 1 plus another 1 plus 1, and the 1 times 1 is 1. So if I have 1 human right, 1 plus 1 is 2. And then 1 times 1 is 1. That would be 3 human total. If I have half, that would be half times plus a half. Half is a half is a quarter. Half plus a half equals 1 plus 1/4, 1/2, 1/4. So that's the quarter right I share with some other person disabled. But it shouldn't be so. So this is open stance initiative. So basically, open motor. So basically, if someone's disabled or fully or half a dimension, they can have the sensory output of a problem. So they can have Andy, I believe Andy can give them half of my liver, but they have half of a dimension and half of a disability. So disability is having half a dimension, not the full dimension. So the difference with your hand that's not working, that's broken. If you lose your human rights, the system should allow you to do it. So this paper represents a fingerprint system. I'm working on a fingerprinting system. So the fingerprint system is to preserve your rights via your disability. So it's open motor, your rights to move, to act on systems, or move first only first, and then you got your right to sense the world, which is open sense framework for sensory preservation. So this is an open motor project here. O for Oscar, P for Papa, E for Echo, N for November, N for Mike, O for Oscar, T for Tango, R for Romeo, open motor. So, my hypothesis: fingerprint and retinal scans are prone to errors given twins or very near relatives. This is a documented fact. Twin sisters or brothers have identical to genophenotypes, presents present genotype and present genotypes and present genotypes. The share genotypes. Genotype just means genetic types of data. Adenine, thymine, cells, guanine, and phenotype means the feature of the hands, how they function. The function doesn't matter whether it's disabled or not. The substrate or the substructure of genotypes classified via a quality assurance matrix allows for mismatch to complementary states. Internal state of the system for the fingerprint scanner or the retina scanner. Um, the stateless and sparse model are actively observer consumer. So basically, the stateless and the sparse, and they can think about the diversity, the genetic diversity of the system over active observer to consumer relationship for the application of a person for authorization for the purpose of authorization and authentication. So the stale protocol for the SIGINT native form. You can log in. You check and log in. So, true positive, false positive, true negative, false negative. Those are the classified matrix. So, this is quality assurance matrix. This is quality assurance matrix. So, as you can see here, the true positive is here on the right side. The false negative, but this matrix are false negative and false mismatches type two errors, type one error. So, type one and type two errors are basically the mismatches. Are the other quadrants on the curve. So you get the me pushing down on this kind of fingerprint. This is my raw fingerprint, but this is a finger moving down on the other. The main points are pressure point. So you get a diagram of a concentration matrix, and you get the pressure point on the surface, and the pressure point on the surface is actually like something. It's not so. This surface has to be springy, and the springy surface repels your hand. So that would be more natural than you pushing it so it doesn't erode. So the surface the thing is basically have a spring surface to erode to push you back, and something that dislocates dislocated dimension of the space, so it doesn't erode more components depending on more how angry you are. So this is one situation. For example, if you have a paintbrush and the paintbrush also has a pressure, basically it's a paintbrush model. So the more pressure I have a paintbrush, the more texture I have, the more color I have, intensity of color I have, the more color there's there. So the more color I have. But if I have to put too much pressure, I get wearing and tearing of the paper. So I get erosion, and the system erodes the paper. The medium is operational, and that medium is what the paper one refers to the paper. So this one is folded 6 times, no 5 times. I can fold it one more. It can erode based on the data, and the data is basically the paintbrush, which is the fingerprint that puts the data down. But it's not a byte. It should never be. It should be a ternary in SIGI classifier for a breadth life and work over a stateless protocol, which is a stateless and an active protocol that knows what it's doing, something that knows what it's doing. Which is like a non-stateless format tomato trade. So this is basically a mixed a blend of mismatch category. This is an illustration. So illustration you never go to of OpenSys. So I'm gonna work kind of system here. So we get the fingerprint present a hardware limitation using a paintbrush scanner intensity and with a dynamic interface. So the dynamic interface is meant to be dynamic because it's not a binary, it's a dynamic classifier. So it should use binary. So it should opt into ternary systems to classify. If binary is not good enough, because binary data erodes the system as well. If it gets corrupt, so we got a ternary classifier via Insigi Trident protocol, and it should work with the 3-pointer rule. Because once to hold things in memory, and a mapping between usually Fahrenheit and the surface of a false mapping between 32 Fahrenheit, which is equal to 0 newtons of force. So we can measure the person's force, and the person's force is basically measured in Fahrenheit. So if the body is 32 Fahrenheit and they add additional pressure, you should be to calculate the force calculated. So sorry for that. To calculate the system in Celsius. Celsius is the baseline for the system acting on, but the threshold, I mean, 32 degrees Fahrenheit baseline. The threshold is in Celsius. So there's a department of 32 degrees Celsius Fahrenheit, which is 0 Celsius, 0 newtons, to map to force to power. And this is the sensory dimension of pressure, where via open motor, open motor, means like people, let me try to log in first. Let me just try and push first. And pressure of sensory derivation should dictate the power of the ratio over a dynamic scale. So dynamic state model is very important to have. It's one of the most important things. So you don't get what I'm saying. So dynamic state model is this. So you get say you get a net surface of a cube, or which is a net cube, and you get the corners which are circles, the edge corners are circles, circles, and you get the lines, the edge corners. That's a not not the edges. They're not the edges like this, which are the pointy edges or the sharp corners, which are just the kind of corners you can carve a paper to. You can have that as lines. So this model is a cube dimension, but this cube is not a circle. It's not a circle. It's not a ellipse, but it should be an ellipse to my favor. So because there's more pressure in an ellipse. So this is a cube, but the surface of the cube is the net. So I'm trying to apply pressure to this net of the face, but I don't want the dimension to rub the components in the net. So I have to have another set of components which are away from net. So I have three nets maximum to solve the problem. So I can push on down on two nets, and on the second net, it should reach the threshold. So so you have two cube faces on top of each other. You're going to stack, and these two cube faces allow to you to push your pressure based on your thumb, and your thumb will be this kind of surface, the thickness. So the thickness I'm allowed is just like let's say you have something that's a cube. A cube can fold. A sheet of paper can fold 9 times. This is only 6 times folded, so I can fold this paper 9 times. So this is 6, 7, 8. So this is 7 times. So this is 7 times. But I can fold it 9 times. It's only 2, and that'll be the dimensions for it. So it can be a component that takes pressure, that handles pressure well, instead of adding more solution and using natural material to add more sense to the system. So this is why I'm asking you fold the paper 7 times, 8 times, 9 times. You are collecting more data. And more data is easy to log into the fingerprint system. And that's what it was. So the goal is to have the cube folded 9 times, the sheet folded 9 times, and get the sheet folded and get a easy component on the sheet to make the net. And the net will be make the cube. So when you make the net of the cube, you then use that to have two sets of nets. You then copy that net into another design and get two cubes, and you can use then you can start pushing down on the cube. But there's a dynamic scale there. So the dynamic scale is the Fahrenheit to Celsius degrees. So in the third image, as you can see, there's a surface net here, and the edges are pointing up. These edges are literally the circles, and the circles represent the corners of the net. So when I push down on the corners of the net inside, I have this is side view, I think. But this is like a flat view. So I've already put this into a cube. So I'm pushing them on the surface. And these surfaces are probably inside, because it's a cube already. So when I'm pushing down on the corners, inside the surface, when I push down, it's meant to measure the threshold of my fingers. But these are bumps, so this is a bumpy surface. So the more circles you have, so this is next to okay, so this is the next of a surface. So you get to the cube, and you get the thing folded right to the cube. But you get the kind of connection between the net and the surface. And so the more I push them, the more I can get warning. So this will be color coded. This kind of circles will be color coded here. So this will be like a red, green, blue. So it's basically holographic. So it could be blue, red, green, and blue, depending on the LED light I see. I determine whether to red go. So I know there's a pressure problem there immediately just by looking at it, or I can use via the threshold. So how this works is basically if you get if you get to two dimensions and you push too hard, and so the first dimension will let me see red, green, and blue. The second dimension will disconnect me. So how this will work is if the power is 64 newtons and above, which is less than 64 newtons, which is like which is like some goes to some kind of power unit, you can have that be okay with getting that because that's basically the force of a human being of a thumb. But if you have that threshold more than 64 newtons to 128 newtons, then you have some kind of application. Yes, you have 64 to 100 less than 64. So if pressure less than baseline, more than baseline, if pressure if pressure more than less than equal to 32 degrees Celsius newtons and less than equal to and more than equal to and less than equal to 64 newtons of pressure, the baseline, um, then you are okay to press. Then you get green. Then you get green. Then you get blue. But then and then when you unrelease, you get green. Unrelease. So you get events on and off. So on push, on press down, on pressure, off pressure. And you get if in pressure. So basically, this is a macro that tells you on pressure, and then if not in off pressure, it's a binary value of true or false. And then you get else if newtons, if power, if pressure on, off, and system is so basically this sets the color LED color to blue before when the pressure is basically in the threshold. But the threshold, so you get red, the mapping. So if your pressure is the pressure is 4 to 208 newtons, you get blue blue. But blue is basically a color coding of it's basically this is a piecewise functor. So you get a function with a function. So you get a function between the red and green, but red and green and blue. You get pressure. You get one of them at each time based on some kind of how you the closest locality to the system, the closest edge that's basically being considered into a net of a cube. So that's the pressure setting that should sustain people for now. But I'm concerned. It works on piecewise elimination. So piecewise elimination, which is like parameter true false. But using dynamic program to do this. So it doesn't do that. It doesn't wait. So it uses sort of a piecewise function. But this function of function uses a piecewise elimination. To eliminate use dynamic programs. It uses tabulation and tabulation, which is bottom up algorithms for partial structures and special substructures, and then top down, which is normalization techniques to map all problem solutions to one apple. Thank you guys for watching the video, and if you have, you can subscribe if you want to subscribe, but if you want to open access, but you don't get paid. Thank you, Namdi. Love you.